So for you and your partner, here's your first premise today. This function is looking at the value of a computer. Without even seeing this, you probably can imagine the value of a computer in general over time decreases. All right. Based on this graph, I need you to give me the following. The purchase price, the value when x is 1. What does f of 1 mean? How is it changing year to year? Give me a function. And what is it worth after 10 years? With your partner. Let's go. So who can help me out? How much was this computer when it was purchased? All right, RJ. $400. And we know that because the y-intercept right there. Okay, what is the value when x is 1, Bob? How do you know? So you're splitting the distance between the 400 and 100? Okay, so it's 200. Who can tell me what that means, f of 1 in context? Emmett, what does that mean in context?
F of 1 is the first year.
So after 1 year, okay, how much is it worth?
200.
Okay. And then who can tell me how it's changing year to year? Willett. Multiply by half, which would give us a decay factor, right? There's half left. Who can help me with the equation then that defines f? All right, Asher.
F of x equals 400 times 1/2.
Okay, yeah. Initial value times my growth or decay factor to the x number of times. So let's see, 10 years. Are we going to get to $0? No, how much is left after 10 years?
39 cents.
That seems like a pretty good deal if it still works, right? 39 cents after 10 years. So,
But it never reaches 0.
yeah, theoretically, will it ever theoretically reach 0?
Yes. Because you can scrap it.
No, but
No, but
you can't have less than a penny that you can
can't
pay
have
for.
less than a
But, so that's why I use the word theoretically. It'll always have some value theoretically. Or you can take it to Comprenew and they'll take out all the parts and sell those. All right, so here's two exponential functions. Your job is to find the function and tell me the value when x is 5 for each. So this is really good practice. This is probably one of the harder things on the quiz, being given a function and then just writing the function for the picture. All right, so just a quick reminder, all of our exponential functions have been in this form every single time, right? A times b to the x. So with your partner, I want a function and what the output would be with an input of 5. It's closed. So let's work on a function for writing a function for the first function, y equals. Who's got my initial value? Tess? And what's happening to it, Tess? Well, it's tripling. Yep. Okay, so if I slap a 5 in for x, we get?
2,135. Or, sorry, 1,200.
Yeah, I got 12. I was going to say 1,255? 215. All right. Excellent. So this next one, we have a decay. What's it starting at, Chuma? And what's happening to it? By half. This one's the trickier of the two, I think, because we don't have a 1 here, right? So it has to go 10 then 5. So that has to be half. Chuma, what'd you get after 5 years? 5/8, 0.625. Yeah. I like 5/8. That is 0.625. Most common wrong answer is that's a 1/4. So be careful because it has to be per 1. If it skips a gap, you got to use guess and check to fill the gap, okay? All right, last thing. We're talking about mold, okay? So there's some mold growing on this wall. Mold A, or mold F and mold G, or I guess function F, which is mold A. Function G, that's mold B. A is doubling every month. B is tripling every month. It's your job to decide which one's which. How you know? when it was spotted, which one was there more of? And then what does point PQ tell you? You're going to work through these with your partner. So which graph represents each function? Please tell me how you know. All right, Nancy, which one's which and how do you know?
Function f is the dash line, function g is the full line,
Okay, how do you know?
because g,
Mm-hmm.
if the full line because it goes up like less, it has like the growth factor.
Yeah, okay, so G is tripling, so it gets steeper. F is doubling, which means not quite as steep. Okay, thanks, Nancy. That's good. So we're looking at the growth factor here. I'm just going to write that down. Okay, when they were first spotted, how do we know which one's which then? Micah, how do you know which one's which then?
I know which one is which by the steepness of it.
Okay, so which one had more when they started?
So A had more when it started because I can see that the line.
Yeah. A had a higher y-intercept. Okay, and who can tell me what point PQ means in context? Yeah, Monica.
And then they had the
Same amount of mold. Which this is kind of cool and scientific. I don't know if you know this. A lot of things in nature will compete with each other. So like, a lot of times multiple things do exist together, but sometimes one thing will like push out the other thing. So I'd be interested to see what happened here over time when they ran out of wall. Like viruses compete for space, bacteria. That's why I like yogurt. If you introduce good bacteria and let it take over, it's harder to get bad bacteria in it. It's like a preservation technique. It's kind of cool. So a lot of these micro things, microbes and viruses, they'll like compete. Eventually though, what would happen on this though? They're exponential, but they're going to run out of what eventually?
Wall.
Yeah, so I'd be interested to see what happens when they run out of wall.
Maybe they'll just take over the entire node.
Oh, it's going to take over the whole world. Look out for this mold if it keeps going, right? All right. I think you guys got it. Lesson summary. When you are done with the lesson summary, homework's in the basket, but you also need to make sure you check your review and ask me questions because the quiz is tomorrow.